Week 7, Lesson 3. Okay, so this lesson is going to be really dependent on how well you remember binomial expansion. I don't really care which way you do binomial expansion. So we did two different worksheets. They were sort of back to back. One was the way you learned it last year, and then one is sort of the new way you learned it this year, which was a lot more like calculator based. Again, whichever way you like better, I'm just going to kind of show you how I'm going to approach this problem. So for problem number, or letter, it's not even a numbered or lettered. What the heck is wrong with me? Anyway, we're trying to find the values of A, B, and C, which you can see here, here, and here. Okay, so what I'm looking at here is this is a binomial expansion, right? This thing has 6 terms. 2, 3, 4, 5, 6. I may not need all these blanks, but I know that I could expand all the way. All right, and if you remember, each of these blanks has 3 things. It's going to have something to do with the 1, something to do with negative 2x, and a number that we need to put in there. Okay, so the first one always has a coefficient of 1. Then you take that first one and you raise it to the highest power, and the negative 2x will be raised to the 0. And then if you remember the pattern, this one is going to have a coefficient of 5. The 1 will be raised to the 4th, and the negative 2x will be raised to the 1st. The next one, let's see, it's 5 times 4 divided by 2. This is a 10. The 1 will be raised to the 3rd, and the negative 2x will be raised to the 2nd. Okay, and then the next one, we have reached the middle, so now the coefficients start repeating themselves on the way back down. This is decreasing, the negative 2x's are increasing, and I think this might be where I get to stop. And the reason that I say that is C, the C right here is next to x to the 3rd, and that's kind of what I'm seeing over here. If I need to expand more, then I will. So this term is going to line up. In fact, let me grab a highlighter. Let me see if I can highlight some stuff. This is I'm gonna be able to find from here, and this I should be able to find from here, and this I should be able to find from here. Right? That's what lines up. So what I need to do is just simplify each of those blanks. So this first one, let's see, this is a 5, this is a negative, so this is negative 10x, which means then if this sort of lines up, A is negative 10. Okay, for this blank, let's see, this negative 2 squared is 4 times this 10 makes this 40x squared. So if this sort of lines up with it, B is 40. All right, and then this last one, let's see, negative 2 to the 3rd is negative 8 times, this is negative 80 x to the 3rd, which means that C would be negative 80. Okay, so let me scoot this up. Excuse me. All right, so on this one, the A is actually this exponent, and we might actually be able to figure out what A is just right now, because if this was expanded all the way out and this exponent is an 8, that means that A must be 8. Okay, so let's go ahead and expand. It doesn't look like I have to expand very far if I only have to get to x squared. All right, and I know there's 9 blanks, but I'm not going to even write all of them. Let's just see how far we have to go. Okay, so I need a coefficient. I need a 1 raised to the 8th, and then I need x over 3 raised to the 0. That will be the first blank. The next one will have a coefficient of 8, 1 raised to the 7th because the 1s are decreasing, x to the 3rd raised to the 1st because those are increasing. And then this next one, let's see, 8 times 7 divided by 2, I believe that's 28. 1 to the 6th and x over 3 squared. Okay, so if I simplify this blank, I should be able to figure out what B is. So let's see, I think it's 8/3 x. So B is 8/3. And here, if I square that 3 that's in the denominator, I get 28/9 x squared, which means then C would have to be 28/9. Okay, let me scoot this up. Okay, so this time my A is actually inside the, the parentheses. So let's see what we can do. Let's start expanding. My B is going to be out in front. C has to deal with x squared. Okay, so let's see. So first term is always going to have a coefficient of 1. I'm going to have 2 raised to the 7th, and then ax to the 0. This next one will have a coefficient of 7, 2 raised to the 6th, and ax to the 1st. Okay, let me simplify that, because I think that might help. Actually, I need this one. This is going to be a constant, right? It doesn't have an x on it at all. So here, 2 to the 7th is 128. Ax to the 0, this just equals 1. So, okay, b is 128. B is 128. Okay, so over here, let's see, 7 times 2 to the 6th, I believe, is 448a to the x. Oh, and I know what a is. I do not know what a is. I apologize. I know what b is. But I do know that this is supposed to equal 224. 448a is supposed to equal 224. So if you divide, a is 1/2. Okay, and now that I know that a is 1/2, when I go to expand into this next blank, let's see what happens. Let's see, 7 times 6 divided by 2, I believe this is 21. 2 to the 5th. And then this is going to be 1/2, because I just figured out what a is. X squared. Okay, so simplifying this, let's see. 21 times 32 divided by 4 is 168. X squared, which makes C equal 168. Okay, so let's see. Find the coefficient of x to the 3rd, y to the 3rd in this expansion. Okay, so again, I could expand the whole thing, but I don't really feel like doing that much work. All right, so I know in whatever blank we're in, I'm going to have the x value raised to the 3rd and the 3y also to the 3rd. All I'm missing is the number. So this might be where you have to use the new method, right? Where this number out in front is the exponent and this number here is either one of these. So if you do 6c3 in your calculator, you'll get 20, x to the 3rd. And then over here, we end up with 27y to the 3rd. And multiplying those together, you get 540 x to the 3rd, y to the 3rd. This is the answer to that problem. All right, and then scooting this up, find the term independent of x. Okay, what that means is we want the term that has x to the 0 power. Okay, now this one's slightly different though, and here's the reason why. It's different because this term has x's in it and this term also has x's in it. So what we're going to do is we're going to use the general term. So the general term looks like this. I know that when I need a coefficient, I'm going to use the 6 and some number. And the number here kind of depends on the exponents over here. So one of these terms is going to be x squared, and the other one is -1 over 2x. And if you remember, these two exponents have to add up to be 6. So I'm going to let this one be r, and this one be 6 minus r. Okay, so now, and this is where it's going to take some heavy-duty knowledge of exponents and how they work. So here, I know that I can just multiply and get 12 minus 2r. Here, I'm hoping you recognize that I can change this into -1/2 to the r times 1 over x to the r. And the reason I'm doing that is I want to find a way to get this to combine with this. So if you recognize, this one little part is actually the same thing as x to the negative r. So if I put it together with this one, I now have this, 6cr x to the 12 minus 3r and the negative 1/2 to the r. Okay, now think back to the way the question is worded, right? It says the term independent of x. So that means if this equaled 0, this term would not have an x in it. So all I have to do is say, okay, well, 12 minus 3r has to equal 0. 12 equals 3r. r equals 4. All right, so if I take the 4 and I plug it in here, right, so this term goes away, I get 6c4 and negative 1/2 raised to the 4th. And putting that in your calculator, you should get 15/16.